Hello OT learners, and welcome to the continuation of our variation series where we'll be talking about joint variation. This is the online tutor, and coming right up is the joint variation tutorial. Right, so previously we talked about direct and indirect variation, but today we want to talk about what a joint variation is. Now, I recommend you to go and watch our previous tutorials on direct variation and inverse or indirect variation. In that way, you are familiar with the topic of variation and you can easily proceed to study joint variation. So let's go ahead and have a definition of what a joint variation is. So we have a joint variation when there are two or more quantities related to each other. This can be a combination of direct and indirect variation. So a joint variation is simply just the variation that exists between multiple quantities. We realize that in the first two scenarios where we talk about direct and indirect variation, we realize that the relationship were only between what? Two quantities. Okay, and these type of variations we say they are either direct or indirect. Now in a situation where you have, let's say, two or more, for instance maybe 3, 4 or 5 quantities, this type of variation now becomes what? A joint variation. Now, a joint variation can include two direct variation or two indirect variation, or it can be a combination of what? A direct variation or an inverse variation all together coming to form what? A joint variation. So we said a joint variation, we have a joint variation existing between what? Two or more quantities that are related to each other. So let's have a look at some few cases and see how we can express the variation when we've been given a statement involving joint variation. So let's look at case 1, what I will call as case 1. So I have A varies jointly as B and the root of Z. So let's look at that. We have A varies jointly as B, A varies jointly as B and the root of Z. Okay, now this expression can be written in a mathematical form. Okay, so mathematically we can see that we have three quantities. We have quantity A, okay, then we have quantity B, and then we have quantity what? Z. Okay, so the relationship exists between these three quantities. Now we see that A varies jointly as B, okay, means it's a direct variation between A and B. So it's going to be A varies directly as B. And the same way we have A varies jointly as B and the root of Z. So it means A also varies directly as what? As the root of Z. So the square root of Z. Okay, now because this is a joint variation, we combine these two variations to form one variation. Okay, that becomes our joint variation. So we have what? A direct variation over here, we have another direct variation over here. So we combine all together, it becomes a joint variation involving what? Three quantities. So this becomes A varies directly as what? B and the root of Z. So we multiply the two other quantities that A is being what? Jointly variated to. So with this expression, we can easily go ahead and remove our proportionality sign over here, and we introduce our constant. In this case, it becomes A is equal to K multiplied by B multiplied by the root of Z, where A, B, and Z are our quantities. Okay, they are our quantities, and the K, okay, over here becomes what? Our variation or proportionality constant, or proportionality constant. Now let's have a look at another case, which I call the case 2, and see how we can express that. So I'm going to use the statement S varies jointly as the square of y. So S varies jointly as the square of y, and inversely as the cubic root, of z. We have to write this expression mathematically. So let me create a column and use another color for that. So over here we can see that we have one variable, which is our x, then we have another variable, which is our y, and then another variable, which is our z. So the variation exists between these three variables or quantities. So for x, we have x varies jointly as the square of z. This is a direct variation between x and y. So we write that as x varies as the square of y. So this is our first variation, and it is what? A direct variation. Now we have over here and inversely as the cubic root of z, which means s also varies inversely, which becomes 1 over what? The cubic root of what? Of z. And this is what? This is an inverse or an indirect variation. Okay, so if we combine these two, we get what we call the joint variation between what? X, y, and z. So let's do that. To combine it, we simply multiply this and this, okay, whilst maintaining the x and the variation sign. So we have s varies as y squared on the cubic root of z. So we can now remove our variation sign and introduce our constant. So it means s is equal to k multiplied by y squared on the cubic root of what? Of z. So with this basic introduction, let's go ahead and have a look at some few examples to see how we can use the joint variation in solving practical problems. So let's have a look at example number 1. We have z varies jointly as s and the square of y, and inversely as w. If z is equal to 25 when s is equal to 10, y is equal to 2, and w is equal to 8, we are to determine an equation and find the value of z when s is equal to 12, y is equal to 2.5, and w is equal to 10. So this is very easy. Let's go ahead and find a solution for this problem. So we write down our solution. So we have z varies jointly as x. So we have z varies jointly as x as one variation, and the square of y. So we have z also varies as what? The square of y, and inversely as w. So it means z again varies inversely this time as w. So we have a direct variation, another direct variation, and then we have one inverse variation. So if we combine all of this, we are getting what? Our joint variation. Now note, if you are writing this for an exam, please do not write the direct variation and the inverse variation that I have over here. This is just for explanation purposes. You can write these direct variations and combine all of them to form the joint variation. That could fetch you an extra mark, but please do not write this over here. So it means in all, we are saying that z varies directly as x and directly as y squared and inversely as what? W. Okay, so this is how we write it together. So this is, first is the direct variation, so you multiply it with the next direct variation, and then we divide it by the inverse variation, so that gives you the joint variation. So this becomes our joint variation. Okay, so from here we can remove the proportionality sign and introduce our constant. So it means z is equal to x is equal to k x multiplied by y squared on w. So this becomes our what? Our equation in this case. So let's go ahead and find the value of k, substitute it back into this equation, which we are saying is equation 1, and then we can be able to what? Use that as our equation for this example. So let me use a new color or a different color. So we have, when z is 25, s is equal to 10, y is equal to 2, and w equals 8. So we simply have to do what? Substitution of these values into equation 1 to get our constant. Simple mathematics. So we have our z to be equal to k x y squared on w. This implies that our z, which is 25 now, so we have 25, is equal to our k, we do not know, our x is 10, our y is 2 squared, and our w is 8. If we further simplify this, we are going to have 25 multiplied by 8 over here, and that is going to give us a value of what? 200 to be equal to 2 squared is 4 multiplied by 10 will give us 40 multiplied by the constant 40k. So we divide both sides by 40 to get the value of our constant. So our k, which is our constant, becomes this, cross out this, 4 goes into 25 times. So it means our variation constant or our proportionality constant is equal to 5. So hence I can go ahead and write my equation for this problem to be what? Z is equal to 5x multiplied by y squared, all on what? W, as my variation equation, or the equation that I was told or asked to find over here. Now let's continue with the latter end of the question. We are to find z when x is 12, y is 2.5, and w is 10. This is easy. So our z is equal to 5 multiplied by the value of x is 12, then again multiplied by the value of y is 2.5. We square that, then we divide it by the value of w, which is equal to 10. So if we compute this, we get to realize that the top will give us a value of what? 375 on 10. So this is equal to 37.5. This means our value of z when x is 12, y is 2.5, and w is 10 is equal to 37.5. So let's go ahead and have a look at another example. So example number 2. The surface area of a cylinder varies jointly as the radius and the sum of the radius and the height. A cylinder with height 8 centimeters and radius 4 centimeters has a surface area of 96 pi centimeters squared. We have to find the value, or we have to find the surface area of the cylinder with the radius 3 centimeters and a height of 10 centimeters. So let's look at this problem. So we write down our solution. So we have a surface area of a cylinder. So let's say A is our surface area. Okay, so let A be our surface area. So the surface area of a cylinder varies jointly as the radius. Okay, the end is the break, okay, between the variables. So we have firstly the surface area varies jointly as the radius. Okay, so this means our surface area varies as the radius, and okay, the end over here breaks between the radius and the second quantity, and the sum of the radius and the height. So it means the area also varies as the sum of the radius and the height of the cylinder. Okay, so it means we have two direct variations. So if we combine it, we are going to get our joint variation. So this means we have our area is proportional to the radius multiplied by the second variation, which is what? R plus h, as our variation for the joint equation. So to remove our variation sign, we introduce a constant. We have A is equal to K, which is our constant of proportionality or constant of variation, multiplied by R, multiplied by what? R plus H. So let's continue with the second aspect of the question. We have a cylinder with height, so we have height to be 8 centimeters and radius to be what? 4 centimeters. And in that case, the area is what? 96 pi centimeters squared. So let's go ahead, use all these values and find our variation constant before we proceed to the latter end of the question. So if we do the substitution, we get to realize that we have 96 to be equal to the value of K multiplied by 4 into bracket 4 plus 8. This means we have 96 to be equal to 4K into bracket 4 plus 8 will give me 12. And then that 12 multiplied by 4 will give me 48. So from here I have 96 is equal to 48K. If I divide through by 48 to get the value of my constant, it means my K will be equal to, this is supposed to be 96 pi, so remember to add your pi. This is 96 pi. Okay, so if I divide through by 48, I get to realize that 96 pi divided by 48 will give me what? 2 pi. This means that my variation constant is equal to 2 pi. This therefore means that the actual area of a cylinder, okay, the area of a cylinder is given to me as what? The constant, which is what? 2 pi multiplied by what? R into bracket R plus H. So this now becomes my area of a cylinder. Please, for verification's sake, you can search Google for the area of a cylinder and see if the expression we've obtained over here is actually the formula for the area of a cylinder. So let's proceed. We have to find the surface area, so it means the second aspect, we don't know the surface area of the cylinder when we are given the radius to be 3 centimeters and then the height to be 10 centimeters. So we have to find the area. So area we don't know when the radius, excuse me, when the radius is 3 centimeters and then the height is what? 10 centimeters. So let's go ahead and look at that. So it means our area will be equal to 2 pi multiplied by the radius, which is 3, and then multiplied by the sum of what? 3 and the value 10. So this is going to be 2 pi into bracket 3 multiplied by 13. If I multiply 2 by 3 by 13, this is going to give me the value of the area to be equal to what? 78 pi, and then I add the unit, which becomes centimeter squared. So therefore it means that the area of the cylinder when the radius is 3 centimeters and then the height is 10 centimeters is equal to 78 pi centimeters squared. Let's have a look at one final example. We have if Z or Z varies jointly as x and the square root of y, and Z is equal to 6 when y is equal to 3 and y is equal to 16, we have to find Z when x is equal to 7 and y is equal to 4. Example number 3. If Z varies jointly as x and the square root of y, and Z is equal to 6 when x is equal to 3 and y is equal to 16, we have to find the value of Z when x is 7 and y is equal to 4. So let's go ahead and write down our solution. So we have our Z varies jointly as x, so this is our first break, and the square of what? Y. This is the end of our second variation. So we have Z varies jointly as x, which is a direct variation, and then Z also varies as the square root of y. So we have square root of y. So we combine these two variations and we get Z varies as x and the square root of y jointly. To remove our variation sign, we introduce a constant k, which now multiply x and then the square root of y. We have here when Z is 6, x is 3 and y is 16. So we have Z to be equal to 6 when x is 3 and then y is 16. So let's do the substitution to find the value of our constant. So when Z is 6, we have is equal to our k multiplied by x, which is 3, multiplied by the root of what? 16. We have 6 is equal to root of 16 is 4, multiplied by 3 will give me 12. So I have 12k. So I divide both sides by 12 to have my value of the constant. So my k is now equal to 1 over 2, because 6 goes into itself, 1 goes into 12 2. So my variation constant or my proportionality constant in this example is 0.5 or half. So which means my equation for this joint variation becomes Z is equal to 1 over 2x multiplied by the root of y. Now we are to find z, so we do not know z in the second scenario when x is 7 and y is equal to 4. So let's do the substitution. So we have z is equal to half multiplied by the value of our x is 7, and then the value of our y under the root is equal to 4. The root of 4 will give me 2. 2 multiplied by 7 will give me 14, and half of that is still 7. So let's do this. So it means my z is equal to half multiplied by 7 multiplied by the root of 4 is equal to 2. So it means my z is equal to, the 2 here will cancel here, give me 1. So 1 multiplied by 7 multiplied by 1 will still give me the value 7. So it means when my x is 7 and my y is equal to 4, my z, or the value of z, is also equal to 7. So thank you so much for watching this joint variation tutorial. This brings us to the end of our short variation series, where we firstly look at what direct variation is. We also proceeded to look at what an inverse or an indirect variation is, and in this tutorial we learned about what joint variation is. So I'll be compiling these 3 tutorials to make a full video tutorial on variation, and I will be posting it in our variation playlist for you guys to watch. So thank you so much for watching. My name is Samuel Kutuka, the online tutor, and you can follow me on the social media platforms listed below. So you can follow me on Instagram at the online tutor 990, or you subscribe to my YouTube channel where I share educational content all around everything, including mathematics, science, physics, biology, history, PowerPoint, Excel, Word, and motivational tips and study tips that will help you pass your exams and then be the best version of yourself in this life. So thank you so much for watching, and I'll see you in the next video. Bye bye.